Hello students, my name is Ms. Gongora and today we're going to be going over section 13.3, the Pythagorean theorem, distance formula, and the equation of a circle. These are our student objectives. After watching this video, students will be able to understand and explain the Pythagorean theorem, its converse, measures of sides and special right triangles, the distance formula, and the equation of a circle. Let's talk about the Pythagorean theorem. In right triangles, the Pythagorean theorem is used to find out the length of one missing side given the lengths of the other two sides. The side that is opposite to the right angle is called the hypotenuse, while the other side are called the legs. The hypotenuse is always the longest side. Here we can see the Pythagorean theorem formula, which states a squared plus b squared equals c squared. Whenever you see a question, you would plug in the numbers for a and b in order to figure out the missing side, or c squared. Together, we're going to solve this question. As we can see, we have 6, 8, and x is our missing side. So we're going to plug it into our Pythagorean theorem equation and say 6 squared plus 8 squared equals x squared. Now all we have to do is solve, so we need to figure out what 6 squared is, which is 36, 8 squared, 64, and then again equals to x squared. So now we add 36 plus 64, which gives us 100, equals x squared. And the square root of 100 equals the square root of x squared. And therefore, our answer is 10. X equals 10, and the missing side is 10 as well. Now let's talk about the converse of the Pythagorean theorem. The converse of the Pythagorean theorem determines whether three lengths are the sides of a right triangle. If ABC is a triangle with sides of lengths A, B, and C, such that a squared plus b squared equals c squared, then ABC is a right triangle. In this example, we're going to determine whether these following lengths could be the sides of a right triangle using the converse of a Pythagorean theorem. So first, we're going to use our equation. So 51 squared plus 68 squared should equal 85 squared. And again, the reason why we chose these numbers is because 51 will act as A, 68 will act as B, and 85 will act as C. So now we need to solve and make sure that this is correct. So 51 squared equals 2,601. 68 squared equals 4,624. And now we're going to add these numbers, which gives us the answer of 7,225. But we need to make sure that 85 squared gives us this as well. In this case, it does give us the same answer. Therefore, those three lengths are indeed of a right triangle. Now let's talk about special right triangles. An isosceles right triangle has two legs of equal length and two 45 angles. Any such triangle is called a 45-45-90 right triangle. Since we have equal angles of 45 and 45, we are also going to have equal sides. The third side, or the hypotenuse, will equal x square root of 2. In this question, we have a 45-45-90 special right triangle. So again, we're going to look at our pattern, and as we mentioned, both 45 angles are going to have the same sides. They're going to be equal. while the one that is across the 90-degree angle will be x square root of 2. So now looking at our question, we can see that we have 7 to the 45, therefore our other x is going to equal 7 as well. Because as stated, our equal angles means we have equal sides. Now all we have to do is find our hypotenuse, or y in this case, which will be x and then the square root of 2. And that will be our answer. Y equals 7 square root of 2, x equals 7. And now we have found both of our missing sides using the 45, 45, 90 right triangle. When talking about special right triangles, there are two types of special right triangles. The one we just discussed, which is the 45, 45, 90, and the one that we're about to learn, which is the 30, 60, 90. For this special right triangle, we're going to be using this formula instead. For this question, we are going to be using the special right triangle 30, 60 to 90. And we can see in this formula that the side that is closest to the 30-degree angle is 2x. The side that is closest to the 60-degree angle is x. And the side that is across the 90-degree angle, or the hypotenuse, is x square root of 3. So we're going to be using this formula to find out our missing sides in this question. This question gives us one side, which will be x, and we know that 8 equals x because it is closest to the 60-degree angle. Therefore, x equals 8, and we can use this to figure out our other sides. Since we know a is 2x, we can go ahead and plug in our x since we know it, which will be 2 and 8, which gives us 16. So now we have found one of our missing sides, a, which gives us 16, x, which we know of course it's 8, and now we just need to solve for b, which will be 8 to the square root of 3. And now we have found all of our sides. B equals 8 to the square root of 3, x equals 8, and a equals 16 using the special right triangle 30, 60, 90. Now let's discuss the distance formula. Given the coordinates of 2 points A and B, we can use the distance formula to find the distance between the points A, x1, y1, and B, x2, y2. The distance formula can also be related to the Pythagorean theorem, which we will see right now during our examples. But for now, our distance formula is d equals the square root of x1 minus x2 squared plus y1 minus y2 squared. For this example, we're going to be using the distance formula that we just discussed. The 2 points that were given to us are 4, 9 and 5, 3. So in order to figure out the distance, all we have to do is plug in the right numbers into the right positions. For example, x1 minus x2 will be 4 minus 5. Now we're going to add y1 minus y2, which in this case will be 9 minus 3 squared. 4 minus 5 will equal negative 1 squared, and 9 minus 3 will equal 6 squared. Now we're going to figure these out. So negative 1 squared will equal positive 1, and 6 squared will give us 1 plus 36. Now we add those together, and that gives us the square root of 37, which equals to 6.08276. And that is how we use the distance formula to figure out the distance between 2 points. As mentioned earlier, the distance formula can also be related to the Pythagorean theorem. So for this question, our formula or equation will be CD squared equals DE squared plus CE squared. So first, we need to figure out the distance between D and E. So here we can see that we were only given 2 points, C to D, but we can make a right triangle and connect it to E to figure out the distance. In this case, it would be 8 minus 5, which gives us 3. So DE squared would be 3 squared. And now we need to figure out the distance between C and E. So again, we only have C and D, the points, but we're going to make up this imaginary E to figure out the distance. In this case, it will be 6 minus 2, which gives us 4. So now we have 3 squared plus 4 squared equals 25. Now that we have 25, we need to find the square root of it in order to cancel out that square that CD has. So now we know that the distance between CD is 5. The last math concept that we're going to be discussing for section 13.3 is the equation of a circle. A circle is the set of all points in a given plane from the center. Let xy be any point on the circle with the center at the origin, or 0, 0. The equation of a circle at the origin is x squared plus y squared equals r squared. The r equals the radius. However, if the center is not at the origin, or 0, 0, then we must use the equation x minus h squared plus y minus k squared equals r squared, where the center is hk. For our first question, we have the equation of a circle x squared plus y squared equals r squared. And the reason why we can use this equation is because in this circle, our center is at 0, 0, or at the origin. So for this question, 2 of our points that we have are x4 and y5. So all we have to do is plug in those numbers to figure out the radius. So 4 squared plus 5 squared equals r squared. And now we're just going to solve for r. 4 squared equals 16, 5 squared equals 25. We're going to be adding these two numbers to give us 41 equals r squared. And now we need to square root it in order to cancel out that square that the r had. Therefore, r, or our radius, equals the square root of 41. Now, if the origin of a circle is not at 0, 0, then we must use a different equation, which as mentioned is x minus h squared plus y minus k squared equals r squared. So if we know the center is at -3, 4, and the radius is at 8, all we have to do is plug in those numbers and we have found the equation of a circle when it is not at the origin. For this, it will be x minus -3 plus y minus 4 equals 8 squared. Now that we are at the end of my presentation, let's review section 13.3. After watching this video, students should be able to understand and explain the Pythagorean theorem, its converse, the measures of sides and special right triangles, the distance formula, and the equation of a circle.